What is graph engineering? I can tell you what it's not. And what it's not is probably all the content onslaught you've seen lately called graph engineering guides, step by step, Twitter articles, so much content people have created. And I honestly don't even know where to begin. So I'll tell you where I did begin. I started thinking about, well, maybe I should make some of my own content to address some of this. But where do I begin? So I did what probably I think most people did is I went to the AI services and I said, what are people talking about with graph engineering? And that's when I realized I think this is where all this is coming from because every response I got on the topic graph engineering from the AI services was utter trash and nonsense. Now, maybe it's polluted by all the other stuff that has been put out there now, but it was nonsensical. I have no idea what it's talking about. I don't know if this is all rage bait. I think some of it actually is. Um, the other is probably AI slop. And then maybe there's just some percentage of people that, well, they just don't know and they're kind of repeating what other people are repeating. But what do loops and state machines and all the other stuff that people are talking about have to do with graph engineering? Um, Nothing. I mean, that's what comes to my mind when you talk about graph engineering. I would kind of expect people to talk about, labeled property graphs versus RDF graphs, the semantic web. What's a hypergraph? Is a holon a thing? Do people care about holonic systems? Is that going to be the future? Those kind of topics, those kind of things, or even getting into kind of the weeds of graph theory. Undirected graphs, directed graphs, reification, property graphs, key value pairs associated with triples. Like, for instance, most people don't seem to be aware that, like, when you talk about labeled property graphs or even RDS style graphs, all of those are directed. I know, like, that seems kind of foundational, but it seems to be something most people aren't aware of. Because if you go back in the literature, lots of people have written about graphs, semantic networks, graph structures, and they kicked around a lot of these terms interchangeably. Um, and you'll see a lot of talk about where is it undirected? Is it directed? Is it a combination of all the above? But the truth is, in practice, most all graph systems are directed. And you're probably thinking, aha, you're talking about DAGs. No, I'm not actually. Because even if you're talking about a labeled property graph, there we go. If you're talking about an LP, where was I? I was over here. I derailed myself again. An LPG versus an RDF graph, they still have subject. Well, this is mirrored. I probably should have thought about that before I did that. So okay, subject, predicate, object. Okay, that's directional because the subject. I'll get this right eventually. The subject is not the same structure as the object. We're calling it an object. That makes it unique, in which you can have an object. Hey, I got it right. An object be a subject somewhere else in the graph. That's entirely possible, but it doesn't have to be either. So I actually found not too long ago a paper. Actually, this paper is quite old. I shouldn't have said not too long ago. The paper is very old. They did not use the term edge and arc interchangeably, which I thought was really interesting. They argued that, I think I may have this backwards. I'll have to go back and reread the paper. That if you have two nodes connected by an edge or relationship, which makes it an undirected graph, that's when you call it an edge. But if it's directed, that makes it an arc, which I'd never actually heard that before. But you can find graph literature, and this was written by some professors at Stanford a long time ago, too. You can find literature that says edges and arcs aren't the same thing, even though I've always seen them used interchangeably, although I've seen the term arc often used more in European literature, to be honest with you. I see it more there. I and that's kind of uh, these are kind of the things I would think about if you're talking about graph engineers. You'd be talking about this, or you know, how a DAG is just a subset of a graph system. It's directional and it has a finite starting and ending point. It's not, you can't end up in cycles. It's not cyclic. You can't end up in loops. And interestingly, when people have been talking about loops and loop engineering, all of a sudden they're not even talking about cycles in a graph and how you can end up in depending on your query, you can end up just chasing your tail because you have a starting point, but if that if you start following the hops and you end up back in the same cycle, you can just end up in this loop. And but that's not even what people were talking about with loop engineering, which I don't quite understand why people are talking about loops all of a sudden. I don't understand why people are talking about state machines. We got away from state machines 20 years ago because they don't scale, because when you have to add additional complexity to the system and update the systems, that means you have to introduce more states and then you have to create the pathways for those states. It's really hard. It doesn't scale well at all. That's why we created these pub subsystems like Pulsar, or well, Kafka is kind of it's sort of a pub subsystem, but all the clouds have their own pub sub data fabric that's very foundational to how they deploy their systems internally, because pub subsystems rapidly scale because all of the data is being pushed along the same fabric and you're just able to configure topics and publishers and subscribers, and that's all you have to do to scale up the system. But yet people are talking about state machines, and that has something to do with graphs. I don't know what to say. It could be a rage bait, it could be AI slop, but it got me started thinking about something that I do think is related to all of this. And mathematically, we have some kind of terms and some constructs to deal with this exact sort of problem. When you have lots of data, or do you have enough data to be able to come to trends that you can use to provide insight? You're probably already thinking about the term that I'm referring to, statistical significance. You have data, you form some sort of analysis of it, and you come up to like things like averages, means, modes, medians, all sorts of trend analysis. You've placed it on curves, the standard deviation, confidence intervals, all that sort of stuff. And you were able to calculate a statistical significance to say, like, can I really use what I found in this data analysis to take action on? That's what this means. That's what statistical significance means. And that's well understood. That's well established. What we really need in this graph engineering discussion is a concept of semantic significance. Okay, what do I mean with semantic significance? Well, I just so happen to be talking about an example today, which I think might help. And it's a really simple example that I actually used in one of our last videos to kind of show some of the explainability features in TrustGraph, the explainable AI features in TrustGraph. And this is one of those examples that I find when I kind of go through it to people, they have this like, oh, I never thought about that before. Oh, yeah, you're right. Oh, yeah, you're right. And it just seems like the train starts leaving the station, and all of a sudden there's this flood of aha moments where they go, wait, why isn't anybody talking about this? So what am I talking about? So if you remember, we have some data that Mark had collected on some NASA deep space missions that are in the TrustGraph playground. And I decided an interesting question to ask would be, tell me about Voyager 1. And then I would also say, tell me about Voyager 2. And remember, Voyager 1 and Voyager 2 are these deep space missions that were launched by NASA back in the 70s, if I remember correctly. And they're still sort of going. They've actually hit interstellar space. I intentionally said, tell me about Voyager 1 or Voyager 2 because it's an ambiguous There we go. I'll get my words out. It's an ambiguous request because when I say tell me about Voyager 1, for instance, that could be almost anything. Like if I say, well, it's a deep space mission that was launched by NASA in the 70s. Okay, that's true. That's a fact. It flew by several of the planets and moons in our solar system. Actually, I don't know if the moon part is right, but it flew by many bodies in our solar system and photographed and read data, etc. Well, that's true. It's it's still going, but it's barely operating and it's out in interstellar space. Okay. So where is the boundary? When I say tell me about this entity, what's enough? How much detail do I want? How much facts do I want? Or do I want, speculation? Do I want opinion? Do I tell me about Voyager 1? Does that mean I want to know, was it a good idea? Was it a bad idea? Was it a good use of money? Was it good science? Was it bad science? I don't know. If you told me that it was a great mission and for these reasons it was scientific first, it was revolutionary, well, that could be valid. Or if you told me about the economics of it, that would be valid. So where are those points? Now, my intent in the context, that word, of an explainable AI demo was to show that we wanted to limit what the query returned to the data that we had populated into a deterministic context structure, a graph structure that you could query, you could audit, you could see. It has explicit relationships that are between the subject, predicate, object, and the reification, etc. That's what my intent was in the context of that demo. But that is in my head. Like, I didn't tell the agent to do that. I didn't even give it any hint of that, but that's how I wanted the system to perform. But what that means is the ambiguity of the request is in direct conflict with the design of the system. And I did that intentionally to prove that point. And these kind of questions, if we're really talking about graph engineering, this is what we should be talking about. This is the problems that we should be solving. And I'm here to tell you, and you probably remember my conversation back with, Vicky Frowen, where we talked about some of this stuff. These problems are not solved. They are not solved. People have debated these issues and how you try to measure these kind of issues, semantic score. This has been going on for 60, 70, 80 years, if not longer. And the deep learning approach was, if we give these LLMs or neural networks, really, if we give this type of neural network enough data, we run it through enough training runs, it'll kind of figure it out for us because we don't know how to do it. And we've seen time and time again, we saw, again, this Voyager 1, Voyager 2 problem. If you look at the embeddings of Voyager 1 versus Voyager 2, it's almost identical. So how do you disambiguate between the two? Well, the only way you can disambiguate between the two is if you have these explicit context structures, a graph structure, where Voyager 1 is an entity with all these relationships tied to it and only it. And then you have Voyager 2 as a separate entity with relationships that are tied to it and only it. Now, maybe there's some connections that bridge the two, but you have those explicit relationships that tell you, and it's directional, by the way, it tells you which way to flow, that explain what relates to Voyager 1, what relates to Voyager 2, and how you get there, and how you can audit, how you can see it, how it's tangible, how it's not just an embedding space. And, well, this is sort of similar to this. Well, how? Well, I don't know. They're similar. These are the questions that we have to be attacking. This is graph engineering. This is graph engineering. And this is the path to how we get to deterministic outcomes using this sort of technology. And we're going to be talking about this a lot more. The word determinism, you're going to be getting a lot of that very, very soon. And oh, by the way, if you're interested in a platform that's open source that allows you to do, let's be honest, actual graph engineering, there, I said it, I stand by it. Good talk, good talk. I believe it. TrustGraph is open source. It is available on GitHub. If you search TrustGraph on GitHub, you will find it. And if you find it at TrustGraph, Trust, Trust, I'll get it there. I've only said it, a million times in my life at this point. TrustGraph.ai. Much more to come.